Morning. I know we're going to be back in class today, but I want you guys to watch this. So what I'm going to ask you to do is pause the video for about 3 minutes, and without technology, evaluate these statements. So pause the video and figure out what these statements equal to. Okay, so log base 2 of 16, that's 4. Log base 2 of 8 is 3. So this guy is equal to 7. What we can do here is we can go log base 2 of 24, which is approximately 4.5, but again, I don't know exactly what it is. What we can do here, log base 2 of 16 times 8, without having to grab a calculator, I'll write 16 as 2 to the 4 and 8 as 2 to the 3. So this becomes log base 2 of 2 to the 7, so the answer is 7. Over here, using the same basic idea, we have 4 minus 3 is 1. We have log base 2 of 8, which we know is 3. And then we can log base 2 of 2, which is 1. Log base 3 of 27 is 3. Log base 3 of 3 is 1. So we have 4 for this guy. Log base 3 of 30 is approximately 3.1. Don't know the exact answer to that. We'll evaluate log base 3 of 27 times 3 the same way we did before. Log base 3 of 3 cubed times 3 to the 1. Log base 3 of 3 to the 4 is equal to 4. Over here, this will work out to be 2. Log base 3 of 24, something around 2.9. Don't know exactly what it is, but it's an approximate, because log base 3 of 27 is 3, so that's got to be in that range. Here we have log base 3 of 9, which is 2. You can see that we have, when we subtract two logarithms, it's the same as dividing the arguments and then taking the logarithm. And when we add two logarithms, that gives us the same answer as when we multiply the arguments and then take the logarithm. This leads us to the product laws and the quotient laws. I'll put a video on the classroom that you can watch for the proofs of these. But the product law is log base anything of a number plus log base, same base of another number. We can take that statement and we can write it as the logarithm of the product of those two arguments. Now, what this does is it allows us to simplify and sometimes expand, but simplify without having to grab a calculator in a lot of cases. The quotient law, log base b of m, minus log base b of n is, or it's going to drive me nuts, log base b of the quotient of those two numbers. Now again, notice it's not the logarithm, it's not dividing the two logarithms. It's taking the one logarithm of the arguments, the quotient of the arguments. And as I say, pause the video, go ahead, watch the proofs for this. Don't need to do the proof too much. So one of the reasons why these are so useful to us is before we had this calculator, which does a lot of our work for us, laws or logarithms came in tables. We had to paw through them. If I needed to know what log base 2 of 12 is, I didn't have to, I'm not quite that old. I did have a calculator, but in the 70s, I know people in the 70s went to school in the 70s, did logarithms using a log table, which is annoying. I'd rather work with one logarithm trying to find that than two logarithms. So here I can take this, I've got a subtraction sign. So log base 2 of 12 over 3. I take the quotient of the arguments, then take the logarithm. Log base 2 of 4. The power of 2 that gets you to 4, that simplifies down to 2. When you do something with multiples, if they were all addition, it'd be perfectly fine to do it in one step, but they're not. We have 2 addition and 1 subtraction. So I'm going to work from left to right. We have a plus sign. Log base 6 of 72, 9 times 8. And I'll just leave that guy, bring that guy down. And now take log base 6 of 72 over 2. Log base 6 of 36, which is 2. So that entire long statement there broke down into one number. Again, we want to use these because they do help us a lot. Yes, I can plug that into my calculator. Particularly if you have this, but if I have my phone calculator which does logs, I don't want to do this one. It becomes complicated. Much easier to use my laws of logarithms to simplify. And it is going to help us to solve logarithmic equations also. This is not that bad. We have over here, we have the sum of 2 logarithms subtracting the sum of 2 logarithms. So we have base 8, we base x. We definitely can't do this on a calculator. But we have the sum of 2 logarithms that can be simplified to the product of the argument. Take the product of the arguments and then take the logarithm. We also have sum of 2 logarithms over here. So we'll take the logarithm base x of the product of those 2 arguments. So I could go 750, log of 750 minus log of 6, which I will do in a minute. Now I have the difference of 2 logarithms. That can be simplified down to the logarithm of the quotient of those 2 arguments. So we end up with log base x of 125. So that statement above reduces down to log base x of 125. Now, this one here, because we have 2 negatives, what we often do is we'll say, oh yeah, I'll just look here. I have the difference of 2 logarithms. No, I have the difference of a negative logarithm subtract another logarithm. This guy is a negative logarithm. There's a negative sign there. If there's a plus sign, we could easily do that. Now, there are a couple ways to do this. Just work from left to right and do 3 steps. But we can also turn it into what we had above. We could turn it into like this. We can do it in kind of 2 steps. So what I am going to do, I'm going to take out a common factor of -1 from the last 2 terms. So that's going to turn this logarithm into positive, and it's going to turn this logarithm into a positive. So now we can do exactly what we did before. We have log base b of 6, product of 2 times 3, minus the log base b of 48. Now we have the difference of 2 logarithms. That can be written as the logarithm of the quotient of the 2 arguments, which we can simplify the fraction down to 1/8. And if we knew what b was, we could evaluate that. But this is the the identity, working with identities for this one. Doesn't matter what b is, this will be the case. That is equal to this entire log thing up there. Now, there are a couple different ways to do some of these things. Like if I looked at this guy and they wanted me to simplify it, I would simplify just like I did before. I would take the common factors, -1 out, I would simplify that, and then work with this. But that's not quite what they want us to do. It looks like they want us to simplify this and just leave this guy alone, because it's equal to or equivalent to 1 minus log base 2 of y. So if we can get that thing that I've got circled down to equal to 1, that would be a good thing. So I am going to work from left to right. I'm going to take these two guys, x times 2x, so the product of the quotients, the logarithm of that product of the quotient. I'll leave this guy alone for now, and I'll just write this guy, make sure he comes along for the ride. Okay, now I have the difference of two logarithms. So the difference of two logarithms can be reduced to the logarithm of the quotient of the arguments. I'll keep this guy coming along for the ride. Now, the x squares are going to cancel out by our basic understanding of exponents. That will leave me with log base 2 of 2. The power of 2 that gets you to 2. Oh, that's 1. 2 to the power of 1 gets you to 2. And we have evaluated that to where we want to show its equivalent. That's not the only statement that we could do, but that is, in this case, what the question asks us for. Now, this one here is more, it comes off of a question that you would see in a diploma, sort of. We want to know what the value of this statement is if P over Q is equal to 8. Not log P over log Q. It's just P over Q. Now, where do we start? Well, the first thing I think I see, I got a difference sign between two logarithms, but I got this 3. My laws of logarithms don't have a 3 in front of both terms. They just have laws. They just have our laws, right? Our law of logarithms only has a 1. So I can't apply the laws of logarithms yet. I need to get rid of that 3. Well, that's easy. Take out a common factor of 3. There. So we took out our common factor. Now what I have in brackets there is acceptable to be applied to my laws of logarithms. We have 3 log base 2 P over Q. Oh, now I may not have known where I wanted to go, but I did get to a place where now I have P over Q. Well, I have a statement, an equality that we can replace. So we have 3 log base 2 of 8, since P over Q is equal to 8. Now we can evaluate the power of 2 that gets me to 8. I can replace that entire logarithmic log statement with a 3. And my answer, that thing here, reduces to 9 if that's my, or with that argument there. Now, the third one that we want to talk about is the product law. Now, I'm going to just basically do 2 examples. I can't prove it with this because this is inductive reasoning. But I can write 2 log x as log x plus log x. Okay? So I've basically blown it up. I've got log x plus log x. Now I've got the product of 2 logs. So I can write this as log x times x, which is equal to x squared. or sorry, log of x squared. So that case is true. I can write this one the same way, log x plus log x plus log x, 3 log x's. Now, I could do this 2 at a time with the plus sign in between because multiplication order doesn't matter. I can write this as just to extend our product law and deal with this as log of x times x times x, which is log of x cubed. So we haven't proven it, but we've shown it to be reasonably possible. Looking at what we have here is I could, with these two, we had 3 in front and then we threw it up as an exponent to the argument. Same thing with the 2. So if it's a times log b, so log base b of some number c, that is equivalent to log base b of c to the power of a. Right? And again, probably in the proof video that I'm going to put up for you. Now, what this means is we can go back and forth. In a lot of cases, it's convenient to shape the a up to above the c, and sometimes it's convenient to shape the a down to in front of the logarithm. So that is the power law for logarithms. We have a log base b of some number c, that is equivalent to log base b of c to the power of a. Now, this is where it's very easy to, where it's useful to us. I don't want to do this. I really don't. 16 to the 12 is a really big number. But by using the laws of logarithms, I can shape down my exponent. And I've got 12 times log base 4 of 16. I can evaluate log base 4 of 16. Log base 4 of 16 is 2. So this works out to be 24. So if you were to plug that into your calculator, you would evaluate it at 24. I don't like calculators that much. Here is the same thing. Now you can do this by looking at, the power of 10 that gets me to 10 to the 21. Well, we know that answer is to 21. But you can also think about it this way. Shape down the exponent. Now remember, no base written. We're talking about base 10. Power of 10 that gets me to 10 is 1. And the answer is 21. Now, this one here we can simplify with what we were talking about before. We can just shape down the exponent. Power of 6 to get me to 6 is 1. So this guy is always going to be n. So this actually doesn't matter what base it is. Okay. So if you have log base b of b to the n, the answer to this guy is n. Now, I'm not going to show you the proof of this, but if you think about this, 6 to the power of something and logarithm base 6 are inverses of each other. They are going to undo the work. If I take log base 6 of n, I get a number, and then I go 6 to the power of n, I'm going to get n out again. And that is the identity that we have down here. Both of these guys reduce down to an identity of n. I'll go over some questions in class with you. Again, it would be not a bad idea for you to take a look at these questions that are assigned. Bring any questions to me that you have.